designed an engine cooling system. This system is primarily required to keep the engine cool and at its optimal operating temperature. It is located directly within and around the engine. You can see the key components of the cooling system. Let's review the liquid cooling system in detail, gradually complicating the layout. Heat is removed from the engine via cylinder block ducts and cylinder head ducts. These ducts, known as the cooling jacket, are filled with coolant. The cooling jacket is situated around the engine cylinders and serves the primary purpose of removing heat from those cylinders. The coolant doesn't stay in the same place. Instead, a water pump keeps it circulating in a closed loop. In turn, the pump is normally rotated by a belt drive that is powered by the crankshaft. This type of pump is known as a centrifugal pump. The liquid would be cooled too slowly in this setup, causing the engine to overheat. Therefore, the radiator cools liquid through a high-efficiency heat exchange process. The radiator is made up of two tanks with an inlet pipe for heated liquid and an outlet pipe for a cooled liquid. The tanks are linked together by a system of tubes. Fins are added to the tubes to improve heat transfer capacity. These systems are referred to collectively as the radiator core. A drain valve is normally located near the bottom of the radiator. The radiator is also equipped with one or more fans that boost the flow of the air traveling through the radiator in case the system fails to cool the liquid to the proper temperature. When a specific temperature is surpassed, the fan is turned on using the radiator coolant fan switch, or more commonly, the engine coolant temperature sensor. The sensor also displays the current coolant temperature to the driver on the dashboard. Typically, the sensor is positioned near the engine coolant outlet. It should be noted that the cooling system is a sealed system. When the coolant is heated, it expands, causing the pressure in the system to rise. This is required to raise the coolant's boiling point. However, excess pressure must be released to prevent system harm. One of the ways to do it is to use a special pressure cap on the radiator. When the maximum allowable pressure is exceeded, the cap opens, enabling coolant to escape into the expansion tank. When the pressure decreases, the liquid is pulled back into the system. This design excludes pressure in the expansion tank. The tank stores a coolant supply and has free space for liquid expansion. The expansion tank also features coolant level indicators and can be used to refill coolant as needed. This is another design with no radiator cap. Pressure relief is provided in this case by the expansion tank cap, which manages the pressure level in the system in a similar manner by releasing and sucking air. This system is already capable of cooling the engine. However, due to the continuous passage through the radiator, it will take a long time to heat the coolant in this instance, and maintaining the appropriate working temperature will be a problem. This will result in increased engine wear and excessive fuel consumption. To prevent this, the system is equipped with a thermostat. The thermostat divides the system into two circuits, a longer one that uses the radiator, and a shorter one where the radiator is bypassed. When the coolant temperature is low, it will circulate around the shorter circuit bypassing the radiator, thus allowing the engine to reach operating temperature more quickly. When the temperature hits 82 degrees centigrade, the thermostat valve gradually opens, and the hot liquid mixes up with the radiator-cooled liquid from the longer circuit, which ensures that the temperature is balanced. If such mixing is insufficient and the temperature continues to increase, at 93 degrees centigrade, the thermostat will shut off the shorter circuit and fully open the longer circuit, allowing the entire volume of the coolant to circulate through the radiator. You can now see a fully operational cooling system. However, it is missing one critical component the car can't do without. It is the heater core. In this layout, the heater core is integrated into the cooling system separately from the thermostat. The heater core harnesses the heat from the coolant to heat the vehicle's cabin. The cooling system is now complete. There are other, more complicated layouts. They may contain two thermostats, electronically controlled thermostats, as well as more complex cooling circuits that keep the EGR system, turbocharger, throttle, intake manifold, and automatic gearbox oil at the appropriate temperature. It should also be mentioned that the system employs a special coolant with specific chemical features, such as anti-corrosion, anti-cavitation, or non-freezing properties. This concludes our review.
So, ayun guys, yung kung paano gumagana ang ating cooling system. Ayan, so. Ayan. So, since alam na natin kung paano nagwo-work yung ating cooling system, we can now discuss the two types of cooling system. So, three talaga siya. So, mayroon tayong air-cooled system, water-cooled system, and the oil-cooled system. So, yung oil-cooled system is just the same lang din naman siya with the air-cooled system. So mamaya meron tayong i-represent ng video. Ayan, so first one is the air-cooled. Yung pala pinakita sa atin sa video, yun ay example ng water-cooled system. Okay, so first one is the air-cooled system. So it is generally used in small engines that's up to 15 to 20 kilowatts and in aeroplane engines. So usually ginagamit tong air-cooled system dun sa ating mga motorbike. Yeah, and in this system, fins are extended surfaces are provided onto the cylinder walls or the cylinder head and etc. Heat generated due to combustion in the engine cylinder will be conducted to the fins and then the air flows over the fins and then heat will be dissipated into the air. So the amount of heat dissipated into the air depends upon the amount of air flowing through the fins, fin surface area, and the thermal conductivity of metal used for fins. So for efficient cooling, the length of the fins and the spacing between them is quite important. So for larger interspacing between the fins offers larger area for cooling air, but the heating of the air is less, so more cooling air is required. And then smaller interspacing between the fins result into the smaller flow area of cooling air, hence input cooling air is less, and usually fin height varies from 15 to 25 millimeters. So para mas magets po natin, so ipa-play natin yung video. So dito sa video na to na ipa-present ko is makikita ninyo yung differences noong tatlong types nung ating cooling system. Medyo matagal tong video na to. So yung mga videos pala na pre-present ko nasa Google Classroom lang din naman ninyo. So kung gusto nyo siyang balikan, ayan, readily available naman siya dito.
Today's video has been brought to you by Squarespace. What is up, engine heads? Today we're doing a detailed comparison of the benefits and drawbacks of air-cooled, oil-cooled, and water-cooled engines. So first, let's answer the questions, why do engines even need cooling? Well, there's a very simple way to answer that question. Get your hands and rub them together. Feeling the heat? Well, that heat is a consequence of friction, and there's plenty of friction happening inside the engine, but by far the largest source of friction inside the engine, up to about 40% of the total friction, is the sliding of the piston rings against the cylinder bore. Now, the faster you rub your palms together, the more friction and heat you generate. And the same thing happens to the engine. The higher the RPM, the faster the piston rings travel against the cylinder bore, and the more passes they complete in a single minute. And the more they do this, the more heat they generate. Now, if this heat is left uncontrolled, it's of course going to lead to the engine overheating, which is eventually going to cause it to melt, which is obviously going to distort the parts of the engine, leading to catastrophic engine failure. So how do we control all of this heat? Well, the earliest and simplest answer is to use the air that's already available everywhere outside the engine. This means that air-cooled engines don't need any additional cooling equipment like liquids or liquid containers or hoses or whatever. Air-cooled engines cool themselves simply by being in contact with the surrounding air and transferring their heat onto this air. You can easily recognize air-cooled engines by the increased number of fins on their cylinder heads and sometimes even on other parts of the engine as well. These fins serve the purpose of increasing the outer surface area of the engine over which air can pass and heat exchange can occur. In other words, by increasing the outer surface area, we increase the space over which heat can be distributed and dissipated. And that's the basics of air cooling. Obviously, this makes air-cooled engines dead simple. And this has the potential to make them pretty lightweight and their maintenance very easy and their production costs low. But there's a price to be paid for this simplicity. And the first item on that price list is uneven cooling. If we imagine an air-cooled engine in the stream of air, we can see that the front part of the engine does indeed get cooled. But the back part of the engine, which isn't in direct contact with the oncoming air, doesn't get cooled so well. Another major issue is that cooling will be greatly reduced when the engine is stationary. This means that air-cooled engines are more susceptible to overheating if they get stuck in slow-moving traffic. Now, this issue can be to an extent addressed by the installation of fans, but these do of course increase the complexity and production costs, and they also create a parasitic load on the engine. But the main issue with air-cooled engines is that they're inherently limited in their cooling capacity, because obviously we're limited in the extent to which we can increase the outer surface area of the engine with fins. And this limited cooling capacity is one of the main reasons why air-cooled engines typically need to run richer than liquid-cooled ones. Now, running rich refers to the air-fuel ratio inside the engine. At 14.7 units of air mass to 1 unit of fuel mass, the engine is said to be running at a stoichiometric air-fuel ratio. In theory, at least at this air-fuel ratio, all the air and fuel inside the cylinder are consumed or burned during the combustion process, leaving no excess air or fuel left inside the cylinder. Now, if we add more fuel and transform the air-fuel ratio to, let's say, 13:1, we're said to be running rich. 12:1, 11:1, even 10:1. All of these air-fuel ratios are possible inside the engine, depending on the engine, but all of these are rich air-fuel ratios. And in theory, we're going to have excess fuel in the cylinder at these air-fuel ratios. At air-fuel ratios higher than 14.7:1, for example, 15:1, 16:1, 17:1, even 20:1, we're said to be running lean. In theory, there's going to be excess air inside the cylinder at these air-fuel ratios. Now, the more fuel we introduce into the cylinder, the cooler the engine is going to run. This occurs because when fuel is introduced into the cylinder, it transforms from liquid fuel into fuel vapor. But for this to occur, energy is needed, and that energy is heat. So as fuel vaporizes, it absorbs a relatively large amount of heat from its surroundings, and this then reduces cylinder temperatures. This is known as evaporative cooling, and it's the same basic principle behind sweating. When we're hot, our bodies sweat, and this cools you down because heat energy is required to evaporate the sweat off of our skin. And that heat energy is the excess heat already present inside our bodies. So as you sweat, body heat is expelled in order to evaporate the sweat, and this cools you down. Now, air-cooled engines rely on running richer than liquid-cooled engines to ensure that the engine doesn't overheat even when outside temperatures are high and the vehicle is stationary. But running richer than required not only reduces power potential, it also can dramatically increase hydrocarbon emissions, which is one of the reasons why air-cooled engines are no longer present in cars. Another factor which contributes to increased emissions is that air-cooled engines typically require more time to reach optimal operating temperature. This is because their cooling system is always on. The fins are always there and the air is always around the engine. You cannot turn off any of these things. And this is why air-cooled engines typically run cold longer after startup, which also increases hydrocarbon emissions. So air cooling obviously has its limits, but engineers soon realized that they could overcome these limits by leveraging a liquid that's already present inside the engine. But more about that after I take just a few seconds of your time to tell you about Squarespace. Now in today's day and age, the online part of your business can be just as important as the main. Now, the line between air-cooled and oil-cooled engines can be blurry, and this is because all oil-cooled engines are also air-cooled, and on almost all oil-cooled engines you will find the same air cooling fins that you can find on engines that are only air-cooled. The other reason is that many air-cooled engines like the Volkswagen and Porsche Flat 4s and Flat 6s also feature a oil cooler on them, so some people refer to them as being oil-cooled rather than air-cooled. But a clear distinction can be made, and an engine is classified as oil-cooled not by the presence of an oil cooler, but by the fact that a part of the oil is specifically circulated through dedicated channels with the clear intent of cooling rather than lubricating the engine. A telltale sign of an oil-cooled engine will be increased oil capacity. Now, one of the most widely known examples of oil-cooled engines has been manufactured by Suzuki for many years, and these are engines featuring their SAX or Suzuki Advanced Cooling System. This system was present on GSX-R as well as GSF, Bandit, DR, and other Suzuki motorcycles. The increased oil capacity, which reveals their oil-cooled nature, is very obvious on these machines. For example, a GSX-R 750 from the late 80s needs 4.7 liters of oil for an oil change. In comparison to this, an air-cooled only or a water-cooled 750cc motorcycle carries noticeably less oil. Now, the oil pump of the SAX system has a dual-chamber, dual-rotor design. One side of the oil pump circulates oil at a high pressure to ensure the lubrication of engine internals and the prevention of metal-to-metal contact, but the other side of the oil pump circulates oil at a low pressure but at high volumes to ensure optimal cooling. Now, the cooling side has dedicated channels which flow in the vicinity of the combustion chamber, the main source of engine heat, and they cool it by circulating large volumes of oil quickly all around the combustion chamber. Now, the cooling channels also feature small ridges which act as boundary layer breakers. They prevent a zero-velocity boundary layer from forming directly on the surface of the cooling channel and reducing the efficiency of the heat exchange. After this, the oil circulates through an oil cooler, which is essentially a radiator. And a radiator is another device that relies on increased surface area to maximize heat exchange with the air passing through and over it. Now, the oil is distributed to multiple thin tubes that go through the radiator, and these tubes have an extremely large number of very small fins attached to them. Now, the oil transfers its heat away to the tubes, and the tubes transfer it to the fins, and then the fins are cooled by the air. In this respect, you can say that all engines are ultimately air-cooled, and that the liquid is only used to store the heat and transport it away from the source to the radiator, and then the radiator can be ideally suited in the stream of air. And the radiator also isn't limited in surface area increasing via fins in the sense that the engine itself is, leading to even cooling across the entire surface of the radiator. So oil cooling has the advantage of being able to circulate all around the combustion chamber, take heat away right from the source, and evenly cool all parts of the engine. The downside is the presence of an oil cooler, which increases complexity and production costs, but most air-cooled only engines also have an oil cooler, so the only real disadvantage is increased servicing costs due to increased oil capacity. But there's another drawback to oil cooling, and it has to do with the heat capacity of engine oil. Now, unused engine oil has an average heat capacity of around 2 kilojoules per Kelvin. This means that it can absorb 2 kilojoules of energy in the form of heat before its temperature increases by 1 Kelvin. Water, on the other hand, has a heat capacity of 4.18 kilojoules per Kelvin, which means that water can absorb twice the amount of heat before its temperature starts increasing, making water the ideal solution for cooling engines if you plan to make your engines generate a lot of heat. And that's exactly what modern engines are doing. Modern engines tend to run close to the stoichiometric air-fuel ratio in many conditions in order to increase efficiency and reduce fuel consumption, but the closer we are to the stoichiometric ratio, the higher the heat generated by combustion. Also, forced induction in the form of turbocharging or supercharging is present on many modern engines, and that too increases heat. Modern engines, especially those high-performance ones on motorcycles, tend to rev very, very high, and that's another source of increased heat. And all of this, together with ever-increasing demands for power, efficiency, and reduced emissions, tends to make modern engines run very hot. And in most cases, oil simply isn't adequate to absorb all this heat generated by the engine. And this is where water cooling steps in. Oil now has only a secondary minor role in cooling the engine, and the main task of cooling belongs to water. Water circulates through dedicated channels all around the engine block and the cylinder head, meaning that it absorbs heat quickly and efficiently from all around the engine and cools the engine evenly. Now, water alone doesn't circulate through the engine. It's actually a mixture of water and antifreeze. As the name suggests, antifreeze prevents the water from freezing. When water turns into ice, it expands. So if water were to freeze inside an engine block, it would likely crack the engine block. Antifreeze also serves as a rust inhibitor and prevents corrosion, which would occur inside the engine if water alone was used in the cooling system. To ensure proper circulation, a water pump is also necessary, and it's usually driven by the engine via a belt. Although in more recent vehicles, the water pump can also be electronic, which reduces the parasitic load on the engine. As in the case of oil cooling, water is passed through a radiator, and the radiator dissipates the heat absorbed from the engine into the surrounding air. Another key component of water cooling is the thermostat, and it ensures that water doesn't circulate through the radiator until the engine reaches optimal operating temperature. This reduces emissions and engine wear by dramatically reducing the time it takes the engine to reach operating temperature. So water cooling is by far the most efficient and capable engine cooling system, and this is why modern engines have it. But the price to be paid for it is increased production costs, increased maintenance, and the increased number of parts required for water cooling to operate. And there you have it, the advantages and drawbacks of different engine cooling systems. As always, thanks a lot for watching, and I'll be seeing you soon.
So, ayun yung explanation for the advantages and disadvantages of using different types of cooling system natin. Okay. Ayan. So, for the advantages of air-cooled engines, so its design of air-cooled engine is simple. So it is lighter in weight than water-cooled engines due to the absence of water jackets, radiators, circulating pumps, and the weight of the cooling water. And also, it is cheaper to manufacture. It needs less care and maintenance. And then the system of cooling is particularly advantageous where there are extreme climatic conditions in the Arctic or where there is scarcity of water as in deserts. And then no risk damage from frost such as cracking of cylinder jackets or radiator water tubes. One of the disadvantages of air-cooled engines, so relatively large amount of power is used to drive the cooling fan. And then engines give lower power output. Cooling fins under certain conditions may vibrate and amplify the noise level. And cooling is not uniform. And engines are subjected to high working temperature. And then for the water cooling system, cooling water jackets are provided around the cylinder head, valve seats, and etc. So the water, when circulated through the jacket, it absorbs heat of combustion. So this hot water will then be cooling in the radiator partially by a fan and partially by the flow developed by the forward motion of the vehicle. So the cooled water is again recirculated through the water jacket. So pinakita naman dun sa video natin na una kanina kung paano nagwo-work yung ating water cooling system. And then we also have the antifreeze mixture. So this is commonly used dun sa may mga winter or cold climates. So in Western countries, if the water used in the radiator freezes because of cold climates, then ice form has more volume and produces cracks in the cylinder blocks, pipes, and radiator. So yun yung nagkakaroon siya ng crack. So nagkakaroon ng effect yung climate nila doon sa ating mga components ng engine. So to prevent freezing, anti-freeze mixture or solutions are added in the cooling water. So dito naman sa Pilipinas, hindi naman siya, wala naman tayong weather na talagang nagiging snow yung ating, nagiging ice yung ating mga nilalagay na coolant dun sa ating mga cooling system. Ayan, so yung mga anti-freeze solution commonly used are methyl, ethyl, and isopropyl alcohol or a solution of alcohol and water. Yan, so pwede din ethylene glycol which raises the boiling temperature substantially and hence more heat dissipation. Solution of water and ethylene glycol, glycerin along with water, and chromates are used to prevent deposits. So ito naman yung mga components ng ating water cooling system. So we have the radiator, and then thermostat valve, water pump, fan, water jackets, and the anti-freeze mixture. So we also have different types of water cooling system. So we have the thermosiphon cooling. So the system works on the principle that hot water being lighter rises up and the cold water being heavier goes down. Yeah, so yun yung ating thermosiphon cooling. And then we also have the force or pump cooling. So the system is used in large number of vehicles like car, buses, trucks, and other heavy vehicles. So here, circulation of water takes place with convection currents helped by a pump. So the water or coolant is circulated through jackets around the parts of the engine to be cooled and is kept in motion by a centrifugal pump driven from the engine through the V-belt. Ayan. And then cooling with thermostatic regulator. Whenever the engine is started from cold, the coolant temperature has to be brought to the desired warm-up time to avoid corrosion damage due to condensation of acid as well as help it easily starting of the engine. So usually ganun naman yung ginagawa kapag pag nag-i-start ng engine, parang pinapainit muna yung engine bago siya patakbuhin talaga. So yun yung reason pala niya, And then we have different types of thermostat. So meron tayong bellow type valve, bimetallic type valve, and wax type valve. So itong mga valve na dinidiscuss or minimension dito is na-mention na din ba to sa inyong ME Lab 1, yung mga types of valve. Ayan, so yun yung kanilang different type of thermostats. And we also have the pressurized water cooling system. So in the case of ordinary water cooling system, where the cooling water is subjected to atmospheric pressure, and then the water boils at 212 degrees Fahrenheit. But when water is heated in a closed radiator under high pressure, the boiling temperature of water increases. So the higher water temperature gives more efficient engine performance and affords additional protection under high altitude and tropical condition for long hard driving period. So therefore, a pressure type radiator cap is used with the forced circulation cooling system. So the cap is fitted on the radiator neck with an airtight seal. And then the pressure release valve or safety valve is set to open a pressure between 4 and 13 PSI. So ito ay na-discuss dun sa kaninang video. So yun yung pressurized water cooling system. And then, meron din tayo ditong evaporative cooling system. So in this system, the engine will be cooled because of the evaporation of the water in the cylinder jackets into steams. And the advantage taken from the high latent heat of vaporization of water by allowing it to evaporate in the cylinder jacket. So this system is used for cooling of many types of industrial engine. So usually, mas sabang malakihan naman ginagamit itong evaporative cooling system. And even dun sa ating mga planta, meron tayo dyan mga cooling system din. So yun yung purpose ng mga, ang tawag doon? Yung cooling tower. Yan, yung mga cooling tower natin, so siya ay parang yung mga radiator, kung sa small use lang naman kagaya sa mga makina natin, sa mga engine natin, ang ginagamit natin is radiator usually. So sa mga planta, ang ginagamit naman natin na cooling system dyan is yung mga cooling tower natin. So mas malaki yung consumption ng water natin doon since mas malaki yung kailangan natin ma-generate na heat, especially sa mga power plants. Ayan. And then description of different parts of the cooling system. So first one is the radiator. So the purpose of the radiator is to cool down the water received from the engine. So yun yung pinaka-purpose niya. Kaya may maririnig din tayo na nag-overheat kapag wala na siyang supply ng water sa radiator. Ayan, so yun yung tendency or isang main reason kung bakit nag-overheat yung ating engine. Ayan. Kaya kung mapapansin ninyo doon sa mga pampasaherong jeep, di ba usually lagi may bit-bit na coke na may laman na tubig, yung lalagyan ng ano, di ba? Yung mga driver, para hindi tumirik yung kanilang sasakyan. So yun yung mga example natin dyan. And then we also have different types of radiator, which is yung gill tube radiator, tubular radiator, and the honeycomb or cellular radiator. So ito na lang yun. And then water pump. So na-explain naman dun sa video kung ano yung mga use niyan. So meron ding fan. And then we have the advantages and disadvantages of the water cooling system. So for its advantage, so because of the even cooling or cylinder barrel and head, due to the jacketing, makes it possible to reduce the cylinder head and valve seat temperature. And then we also have the volumetric efficiency of water-cooled engine is higher that of air-cooled engines. And then compact design of engines will appreciably smaller frontal area is possible. And in case of water-cooled engines, installation is not necessarily at the front of the mobile vehicles, aircraft, or etc. as the cooling system can be conveniently located. While its disadvantages naman, the system requires more maintenance. Yun nga. And then the engine performance becomes sensitive to climatic conditions, and the power absorbed by the pump is considerable and affects the power output of the engine. And in the event of failure of the cooling system, serious damage may be caused to the engine. Ayan, so kapag hindi agad siya nagawa kasi usually naman kapag kayo gumagamit ng engine or palagi yung ginagamit yung mga makina na yan, usually dapat lagi siyang nagkakaroon ng mga maintenance or minomonitor natin siya para maiwasan natin na masira or ma-overuse yung mga engine natin. Kasi kapag nasira siya, parang mapapamahal pa tayo sa gastos. Ayan. Lubrication. 11 na pa. Okay, so let's continue na lang this next topic. Itong lubrication system by next meeting, which is kailan po yung ating next meeting? Bukas ba yun? Kailan po ang ating next meeting?
Sa Thursday po, ma'am.
So, Thursday. Okay. So, sa Thursday, continue natin yung lubrication system natin. And then, after nitong, kasi last topic na siya for this chapter. So, after nito is, by next week, mag-start na tayo ngayon ng reporting. Okay po ba yun?
Yes, ma'am.
Okay, so please take note para dun sa mga mag-report by next week. Ayan. May question po ba kayo sa mga diniscuss natin?
Wala naman po.
Wala naman po, ma'am.
Okay. So pwede nyo naman balikan yung mga, kung kayo medyo inantok, nakatulog na kayo, ganyan. So pwede nyo balikan yung mga videos natin since nandun naman siya sa Google Classroom. Okay, so yun lang muna for today, guys. Thank you everyone for attending the class.
Thank you po, ma'am.
Salamat po, ma'am.
Thank you po, sir.
Thank you po,
Thank you po.
ma'am.